Hello there, Algebra 1A, and welcome to Lesson 1.6, Represent Functions and Rules and Tables. The vocabulary I have written down here for you, so I'll let you copy that down. Basically, we're dealing today with functions. A function is a relation of ordered pairs in which every x has only one y value. A domain, those are the inputs of a function, what you put in, and a range are the outputs of a function, what you get out. Independent variables are the same thing as a domain. They're your x variables, and dependent variables are the same thing as your range, which are the y variables. So certainly take some time to pause, write that stuff down, and we will get into some examples. Our first example, the input-output table shows the temperature over various increments of time. Identify the domain and range. Okay, the domain, again, is the same thing as the input. So pretty simple that the domain is 0, 2, 4, and 6. So 0, 2, 4, and 6. It could be helpful to write down the unit. We're dealing with hours. The range, on the other hand, are the output values. So 24, 27, 30, 33 are the range values. So simply just identifying which is which. Pretty easy, I hope. And that's in degrees Celsius. It's not covered in this example, but notice how 0 to 24, 2 to 27, this would be a function because every input has a different output. So it's pretty interesting in this table. So that's identifying, domain and range. The next example, domain and range, really should be okay if you want to take care of this checkpoint real quick. The domain is 4, 7, 11, and 13, and the range is 10, 20, 35, and 45. The more important stuff here, identifying a function. Determine if the pairing is a function, explain your reasonings. This first example here, example A, is what we call a mapping diagram. Basically, it just takes your inputs and maps them to an output. If we were to look at these as ordered pairs, this first one, 4 to 1, would be the coordinate point 4, 1. That's going to be our x and y's later on. 8 to 2 would be the next one, and 2 to 3 following that. Now, since every single input has a different output, this is a function. Let me show you an example of something that's not a function. If we simply had the inputs and outputs, and let's say we still had the same numbers, 4, 8, and 2, and 1, 2, and 3. If you ever have this scenario, let's say 4 goes to 1, but it also goes to 2, and the others can be doing anything else. If you ever have this, that is not a function. Because every input has to have one output. With that in mind, if we look at this here, so 2 goes to 2, 2 also goes to 4, 3 goes to 6, 4 goes to 8. If we think of this like our other one, so 2 goes to 2, but it's also going to 4. Since 2 is going to 2 different numbers, this is not a function. So that is the key thing with that there. Not a function. And that's pretty much it for those ones. Determine if these pairings are functions or not. So input outputs. Anytime you see a repeated x value going to a different y value, means it is not a function. For number 3, since none of the inputs repeat, we have all those others, then it is a function. Okay. Equations and some function rules. So a function may be represented using a rule that relates one variable to another. So the verbal rule. So this is just kind of creating things we deal with regularly. 2 less than the input is the output. So what we're doing here is the output. Remember, output is y. Is means equals 2 less than the input. So I would get in the habit, when you see input, think x. When you see output, put y. And what we have is y is equal to 2 less than the input. So if we take the x and we subtract 2, that is the equation. What we can then do is evaluate that equation for different values. So in our calculators, we have the equation we want to use. We can use these different inputs. We can then put 2 in for x. So 2 minus 2 is pretty simple, it's 0. Then we put 4 in for x. 4 minus 2 is 2. Then we put 6 in for x. 6 minus 2 is 4. Then we put 8, and then we put 10. And that's how you fill out our table. Similarly, to make a table for a function over a given domain, like in example 3, we have a function for us, and it wants to know what is the values at these specific domain points. So it just wants to know what's going on at 0, 1, 2, and 3. So I put those in the domain section. The other section then is simply putting 0 in for x. So 3 times 0 is 0. 1 times 3 is 3. 2 times 3 is 6. And 3 times 3 is 9. So the range of the function would be 0, 3, 6, and 9. What we can also do is take a table and try and see what's going on each time. So what we want to notice is, like, how do we go from 3 to 6? How do we go from 5 to 10, 7 to 14, 9 to 18? And you might need to think about what's going on. From 3 to 6, we know that 3 times 2 is 6. So this is 2 times. 5 to 10, we know that 5 times 10, or 2 is 10. So each time we're multiplying 2 by the x value to get the y value. So notice that each output is double the corresponding input. So a rule for this could simply be y is equal to 2x. They shouldn't be too challenging to figure out what's going on each time, but it might be a little bit here and there. Write a rule for the function. Let's see if you can figure this one out. So let's think. What is going on between each of these? 1 to 1.5, 2 to 3, 3 to 3.5, 4 to 6. It looks like it's multiplying by 1.5. So try something out on your calculator. Is it multiplying by 1.5? Well, let's try it out. 1 times 1.5 is 1.5. That works. 2 times 1.5. That's 3. 3 times 1.5 is 4. And 4 times 1.5 is 6. So yeah, that's what's going on each time there. The rule would be y is equal to 1.5 times x. Okay. Generally speaking, there'll be multiplication examples for you. So great job through those, guys, function stuff. So try out the practice problems 1.6 the odds. Do that in the checkpoint, and good stuff.